Hi guys, welcome to episode 2 in our series taking a behind the scenes look at our game Revenge of the Xenomorph. In this episode we'll be taking a look at the game's plot in a little more detail, the characters you'll come across and how they impact the story and the gameplay. We'll also be looking into how we created our game scene using an object-oriented approach to handle attributes of each object needed in any given level. We'll also be looking at how we added dynamic lighting to a 2D environment. And lastly, I just want to quickly circle back and look at an element we covered briefly towards the end of the last video in a little bit more detail. If you've not had a chance to see our last video and you would like to see it, or you wish to find out more about us and see what other stuff we've done, you can follow us on Facebook or Twitter, or visit us at our website www.zombiebothinstudios.ltd.com. Also, we have our new summer game Waterjet vs Megalodon that's out now and is free to download for both iTunes and Google Play from the Google Play Store. If you do play it and you enjoy our game, please just leave a quick review just to help spread the word. So the plot for Revenge of the Xenomorph, or ROTX, is a simple one. Originally the story opening was going to be shown as a short sort of cutscene video at the start of a new game. The story would unfold through a number of still images using a comic book style approach. However, ultimately it didn't feel organic to the game, and the way Corona handles videos, it felt more like a YouTube video had been opened over the top of the game rather than it being part of the game itself. So instead I opted for something I felt was less imposing on the player, allowing the player to either get a brisk idea of the events that had taken place before the start of the game, or for the more adventurous and more detailed account of what transpired. In either case, the player gets an idea of what happened before the game starts, so they can just then jump straight in when they hit new game. How I did this was by building the events of the story into the actual game menu and load screens. So in both instances, the player will see the title, the time period the game is set in, and the arrival of the aliens. And then in the brisk version, the player will then witness one of the perspectives, or one perspective of the player being abducted. With a little explanation there, the player will also then witness a more fuller account of what happened through transmission messages. The story then gets further fleshed out for the player with some of the illustrations shown when the load screens appear between the scenes. So, ROTX is set in a parallel universe in 1948, a year after the Roswell incident where 3 UFOs did actually crash in the Nevada desert. Out of the 3 pilots, only 2 survive the crash and are captured. Out of those 2, one dies in transit to a secret military base, while the last surviving alien succumbs to its injuries during repeat inhumane interrogation sessions. The alien civilization they belong to are aware that their comrades crashed on our planet, that 2 of them were captured by a primitive life form, and that the remaining explorer's life was extinguished through sustaining mass trauma by this primitive and aggressive species. While the aliens quickly deem us to be inferior and overly aggressive life forms, as well as currently being technologically inferior, they still recognize us as a future threat to their plans and decide to take action, while this primitive race, us basically, is vulnerable. It's easier to remove the problem now rather than suffer it later. 1 year after the Roswell, Earth is invaded, much of our civilization is wiped out. Only small pockets of people survive the attack, and they're scattered and frightened. There is little resistance, and most are either killed or abducted by the invaders for experimentation and enslavement. You play as one of the people that were abducted and are now facing this new frightening horror. Okay, so that's a bit of a closer look at the plot, and it kind of just sets the sort of groundwork for everything that's going to follow on in the game based off these events. You'll also meet characters along the way in the story, so as well as the larger story arc going on in the background, you'll also have individual characters' stories progress as the game progresses. And that kind of brings us nicely on to now the characters that you're going to meet in the game, some of them anyway. Some of the enemies and some of the NPC characters. So we'll take a look at those now. So ROTX has a rich array of characters that you'll encounter through the game as the story progresses. This also has an impact on the gameplay as certain characters pose new challenges while others provide alternative solutions to overcome certain problems. The first character we're going to look at is the Alien Warrior. Now, the Alien Warrior, they're skill fighters. They take advantage of both their exceptional intelligence and their extrasensory sort of abilities. That makes them very difficult to outmaneuver, outsmart, and While the alien warrior is often underestimated when it comes to its physical prowess due to its lean appearance, they are actually a lot stronger than they look. With a natural sort of regenerative ability, um, they're also very hard to kill. They're not immortal, but it makes it very difficult, and they have a long lifespan. And that's the same throughout the species. And also they have body enhancing tech, which they have integrated into its almost impenetrable armor. The warrior's armor is multifunctional. It allows the wearer to survive any sort of harsh environment, even deep space. It's also monitors the alien stats, administering sort of medical aid when needed, sort of counteract toxins or stabilize alien when critically injured, and also enhances the alien's natural healing abilities. Now, the alien's natural healing abilities, as I just mentioned, it allows the alien to regrow limbs and organs, but this takes time, and the alien has to enter into sort of like a self-imposed stasis, so it requires a great deal of energy. With the suit, bones, wounds, and organs heal much faster, depending on the complexity of what's being healed and the number of other injuries the alien has sustained. Ultimately, though, while they are tough, as I say, the warriors can still be killed. Now, there is a variant of the alien warrior, and this is the alien scientist. It's equally as deadly in its own right if it gets its hands on you. The alien scientist is distinguished by having no armor, where the alien warrior has heavy armor protecting its chest or upper chest and head, protecting its vital organs. The scientist doesn't need this, and so its face and hands are exposed. It also wears a different colour sort of suit, so that they are easily to pick out from the alien warriors. They hold all the same natural abilities though as the alien warrior. However, they have a much higher extrasensory abilities. It's been more keenly developed with the alien scientists, and that will play also into the gameplay. Now, the next main character we're going to look at is because of the aliens have managed to advance their technology enough to be able to create advanced androids that can assist the alien warriors. There are two main types of androids that you'll come across in the game. The first is the hoverbot that acts like a moving sort of security system, policing the corridors and alerting the alien warriors of your presence if detected. The second is the android hyena. This beast is called in when the aliens have detected you once but have lost sight of you and can no longer find you. Unlike many stealth games, if you do manage to survive being detected by the aliens, they won't simply just forget about you after a period of time. If they can't find you, they'll step up the difficulty and release these mechanical monsters with advanced sort of sensors that they can see pheromones in the air and sniff out life forms from a long distance away. They also have infrared sort of vision. They're able to see through walls, which makes hiding from them once they've got your scent impossible, really. The android hyena moves fairly slow while it's sniffing you out, but once the scent is strong enough, they'll burst into a sort of fast sprint to your location. As an android, the hyena can reach pretty frightening speeds, as well as unparalleled and overpowering sort of strength, with no compunction or compassion when it comes to killing. When they are about, your chances of surviving the level get vastly reduced, so it really just sort of ramps up, the tension and the hopefully the enjoyment as well, because of the challenge of completing the level certainly gets a lot harder. Just to also quickly mention, on board the mothership where you're being held, you're not the only life form being held captive. There are some life forms on there that are quite placid and friendly, and while there's that communication barrier, they're just as desperate to escape the horrors that await them, whereas others are far more aggressive and also overpowering size. So used correctly, both can help outmaneuver the alien warriors, either with assistance or maybe as a distraction, or worst case scenario, just as brute force. Now, with looking at the characters, we've looked at a number of characters that you'll meet in the game, but we've not really talked about our protagonist and the companion you'll befriend during the game. However, I think that's something we can look at in closer detail at a later date. However, for now, we can confirm you play as a young team that is forced to use their wits against physical and technologically superior enemies. At times, the player will be able to take control of the companion to solve certain problems and puzzles, while other times the companion is a non-playable character that can assist you or be instructed by you using its favourite source of food found on board the mothership, which is a sort of a slimy and somewhat disgusting looking type of fruit. Okay, so for the next part of our video, we said we were going to take a look at how we handled and created the basics for our level or levels using an object-orientated approach. So rather than trying to type this out while explaining what I'm doing, I've already written the code, and instead I will walk through each step to explain what's happening so you can get an idea on how we handle different aspects of the program needed to create our level. To do this, we'll look at the game scene, the level manager scene, and grid scene. So first of all, the reason we opted for an object-oriented approach while using a scripting language which, unlike C++, doesn't really encourage that approach is because it makes adding and modifying our game objects later on much easier. As well, with this approach, it makes isolating any sort of object-related problems while debugging our app far easier and quicker to resolve. In short, for writing large programs, this is probably the best practice to adopt. Okay, so here we are in our game scene. As you can see, we're looking at some of the plugins that we have loaded in for this scene. At the top you can see we've got our storyboard and our scene plugins, and that's there, as mentioned before, because of the way Corona handles and structure its apps. It's kind of like going through a storyboard, and each sort of aspect of the app is its own scene. You can also see we've got our a couple of libraries for accessing and loading and saving files, as well as for accessing certain network functions as well. And then underneath that we've got our level manager library, which is going to be key to what we're looking at today. Under that, we've then got our pathfinding library. We won't really cover that in much detail today, as it's something we can come back and look at a later date, but we do need that. And then underneath that, we've got a couple of things relevant to the device. So first of all, we've got the device model, and then under that, we've got the actual height and width of the screen on the device that we're using, or the app's running on. And then underneath that, we then have the boundaries of the screen, so the left, right, and top and bottom, and also then the center of where the screen is. And that's important, so when we're trying to load things up onto the screen, regardless of what device we're using, it appears exactly where we want it to and not off screen or off place. Okay, so beneath that we've got our level table. How Corona works is that it holds everything into tables, and where I tend to normally think or refer to these as structures, because of the different types of information that it's holding in them. They're just tables in Corona scripting, and we'll be holding everything relevant to the level in this, which will be the map, the grid, and the walls and the objects. Okay, so as previously mentioned, each scene is made up of 4 main functions: the creation scene, the enter scene, the destruction of the scene, and the exiting. We're going to be looking at the create scene here, and in this you can see we've created the scene view. So that's a bit like registering your windows in C++. So you register your window and everything is then loaded onto that. Animation is blitzed to that screen. Underneath that we have our level info variable, where we are returning the information from the call we're making in our level manager library function create level. We're passing in the game scene, and then what's being returned from that function is then being stored in level info. Underneath that, then you can see the breakdown of the info from level info being passed into our table. So looking from the code and from what I've just said, you've probably already figured out that what we're actually seeing being returned is a table with a number of subtables within it, and underneath you can see those subtables for the map and the grid and the wall are then being passed into subtables held in our level table. So there's a lot of transferring of information then once we've loaded the correct scene in that we need, or the relevant information that we need for this relevant scene, and it's all being passed from the calling of our library. So next we'll have a look at the actual level manager itself, so you can actually see how that's working. You can see here we've got our plugins, we've got for loading and saving and reading files. We've also got our libraries for the map and the grid and the wall, and that's because we're going to be making calls to functions within those libraries to actually load the relevant information as we gather the information to load into our table that you saw in the first scene. And just like with the scene before, we've got our table underneath where we've declared our 5 main functions for this class. Then we've got a variable for holding the scene view, and then our arrays then for holding the returned information from our function calls within other libraries. That will go into a little bit more detail in a sec. But first of all, if we just have a quick look, you might recognize the create level function here. It's the function that we called in our previous scene. We declared it within the table above, and you can see we're passing in a group, which is the scene view, and we're then holding it within our group variable within our table that we declared above, our attributes table. And then underneath that, we're then making calls to the functions, other functions within our class. Private functions, and you can see then once we go into those functions, they're actually making calls to the libraries that we declared in our plugin. So here we're making a call to the load map function within our map library, and it will load the relevant map to this level and return it and store it in our map array or table that's been held within attributes. And attributes then gets returned back to our game scene at the end. See, we're returning attributes then once we finish calling all the relevant functions. So level manager handles the overseeing of loading in the objects, but libraries like grid library and map library handle the actual creation of those individual objects and handling those individual objects. Level manager simply oversees that. Okay, so onto our grid library. So again, you can see the plugins and also the variable settings that we loaded in for the device, and then again underneath we have our table where we have our function call for create grid, variable for the grid, and then our grid cells, which is a table again that holds the individual positions of the cells and also its relevant value and number, which is important because we're going to be adding a touch event to this, but I shan't go into too much detail about that now. Instead, we'll have a look at our create grid function, and here you can see we've passed in 2 values. We've passed in our map and group, and then from that you can see we've registered our map with a jumper, and we've set a number of parameters for creating our grid, so the number of rows, number of columns, size of the tiles that we want them to be, and the position. We want each one to follow on from the next in creating both our row and our grid. Also the tile image we want to fill, because we're going to be creating a polygon, a square polygon, and then we want to fill that with an image that will make for the actual floor. And so we need to load in the correct floor for that specific level, because we can't have the same floor for each level. And then obviously we're concatenating the actual file name of the image together based on a couple of parameters, and we're creating our reference for the image to be loaded in. I won't go into too much detail about how we actually created the grid, because that's not really what we're trying to look at the moment. We're just trying to look at how we're handling creating data and how we're passing data, rather than the specific bits of the grid and other aspects that will be explained more when we look at jumper and pathfinding. But for now, you can see how we've created our fill image, and then we've declared then our local function, touch function, which at the moment, if it's double tapped, will give us then the coordinates, the actual tile that was tapped, its position and its number value. That's all it's doing for now. We'll do more later on, but we can come back and look at that. For now, it's just a brief overview. For now, we're going to look at the for loop for the column and the row for creating an actual grid. Here you can see again we create our vertices. So this is going to be for our square polygon, our flat square. And first of all, you can see we create a table holding 8 values, which will be the 8 points for our square, and then we actually create the polygon underneath that. Next, we check the actual value of the tile using the column and the row for a matrix reference check, and whatever value that's held for the tile, we use that then to know whether to load an image in to fill the actual tile that we created, our polygon tile, or whether we just fill it with a color with a paint. And underneath that, we just have a quick call to alpha channel, making sure that all tiles are visible, overriding any previous calls, just so we can check to make sure the correct tiles are being filled with the correct either image or paint while we're in editing mode. Also, again, based on the values using our column row as a reference on our map matrix, depending on the value within the tile, depends then whether we add a touch value to it, a touch event, I should say. So if the equals 0, then it's a walkable path, and so then a touch event needs to be added to that tile. So if you double click on it, it becomes the destination for our pathfinder from where you are to move the character to. And then we're passing all that information, all that tile information, then into grid cells. Remember our array and attributes. We're passing the individual tiles into that array for referencing then later on. Okay, so we've got the basic idea on how to handle objects within our game, and in Corona that uses a sort of table-based system approach to handling data. As we advance through the episodes, we will look at this in more detail as well as other aspects, techniques that are useful to employ as we cover different aspects from handling the game, AI and controls to the enemy and non-playable characters and such. Okay, now to take our project to the next level. To give our app a professional finish, we're going to take a look at adding dynamic lighting to our 2D environment, further blurring the lines between 2D and 3D gaming. Remember, while dynamic lighting has been around for a while, it's only now in this console generation we see 3D gaming using it in abundance, and that's because of the processing power that it requires. That's not quite the case with dynamic lighting in Corona, so it's kind of giving 2D mobile gaming a slight advantage in the case against 3D, 2D sort of mobile games. So what is dynamic lighting? Well, to explain that, first let me explain what static lighting is. Static lighting is a fixed light source that doesn't change, so any surface affected by the light and shadows cast by the light source is processed when the light source was first created, and never again for the rest of the time the light source exists. This is often used in games as it's easier on devices and graphics cards. Dynamic lighting is the opposite. It's a lighting source where either its properties change throughout its existence, or the object's properties it interacts with changes so that the shadows cast and the surface affected by the light source needs to be constantly checked and changed accordingly. This is a reason why the minimum number of dynamic light sources is used in a level for both 2D and 3D gaming. Though the process power needed for 2D dynamic lighting isn't quite as intense as it is with 3D gaming, this, as well as 2D gaming tending to be less of a strain on game processors, can really give you a sort of edge and really just, take your app from looking good to exceptional and really stand out. So we're going to take a look at the Corona Marketplace and where you can get a plugin just for this very thing. Okay, so we're in our Corona Marketplace, and you can see the dynamic shader that we're going to be using, the plugin. It was created by a brilliant software company called Sportfin Software. It's such an amazing program. It's so easy to add as well. It's worth every penny that it costs. So it's definitely a value buy. There's a brilliant description as well that just gives you a bit more of an idea exactly how it works, and also then some diagrams below which just kind of shows you a sort of visual aid of how it works. So as you can see here, we've got an image of a sprite character where it's had dynamic lighting added to it to see the light and the shadows hitting the character through using this shader plugin. It gives you also a bit of an idea from other game snap pics, of what it's like in an actual in-game environment where you've got multiple characters and shadows and lights being cast. And as I say, it's just so easy to add to the game. It's so quick that it really, it's no effort at all to add. Okay, so how to add it? Well, it actually gives you an example as well, which is what we're looking at here. So it just says all you need your sprite, create your normal, and then load that into your game, and you'll be able to create the end result that we've seen demonstrated. It gives you a couple of ways of how you can actually do this. You can either use a sprite illuminator, where we'll give you a bit of an example of how you actually create the normal in that, but you can also use GIMP 2.8. If you remember, I was mentioning it that last time. I can give you the link to the plugin where you can download that and add that to GIMP 2.8. As I say, it's got many powerful tools that people have kindly created for it, and you can add that and use that to create your normal. And then it just kind of shows you then how to actually add it into the code. So it kind of shows you, you create the plugin, you load that into your level, like where we looked at before about adding plugins. And then once you've added the plugin, you then just create an object. You load the sprite into that object, create the positions of it, and then you create a subtable where you actually load in the shader, which is a table which holds both the sprite object and the normal object. And you then add that object then to the dynamic shader. As you can see at the very bottom, we add that object in our add object call function, and then we add our actual light source. So you can see there we're just creating a light source in a fixed position. It doesn't have to be, and that's what's used to actually create the dynamic light. And then it's simply just a case of starting off the shader, and that's it. That's all it takes to add such a powerful plugin to your app. It's quite a short bit, this bit, because of just how quick and easy it is to actually add to your game. So we'll look at the last bit now that I mentioned that I wanted to circle back and take a look at. In the last episode, we looked briefly at the benefits of adding a joint frame to an object to move and animate objects. We showed this with an oak crop, so we could animate it blowing in the wind, which is fine. Using the joints is brilliant, specifically if you want to create animations of characters walking and moving and things like that. However, Cinema 4D has a number of powerful tools, particularly effects and emitters and distorters, that I wanted to show quickly, just how easy it can be to add a wind effect to an object. Okay, so to add a wind effect to an object, it's easy. All you need to do is go to the top corner where you'll have a little arch sort of character bend effect. Click on the little arrow beside it and it'll come down with a number of other effects. Find wind, select that, and then once you've selected that, add that to your object, and then you'll see already a deformation happen to the actual object. You can see we had a flat plane polygon and it's now already distorted. Then underneath on the right hand side, you'll have a number of object items which allows you to change the amplitude and other effects which will decrease and increase the overall strength of the wind billowing. But already, as you can see, it already adds a wind effect for you, and it's just that simple to add. And it's just something I wanted to quickly come back to and look at as I just wanted to make sure we covered that as well. I mean, we'll cover Cinema 4D effects as well in other videos, but I just wanted to quickly cover that in a little bit more detail because of touching on the subject briefly in the last episode. Okay guys, that's everything for this episode. I hope you've enjoyed it. If you have enjoyed it, please just like this video, and if you haven't already, please subscribe, as we have many more topics we can cover. If there's anything in this video you want to find out more about, or any topics you want us to cover in the next video, please just let us know. Again, if you want to see more of what we do, you can check out our website or follow us on Facebook or Twitter. But that's pretty much it for now. Thanks guys, bye.